For watching this video titled Medians and Centroids, what I'm going to do in this video, go over a median, define what a median is, define what a centroid is, and how we can use it to figure out the links on a triangle and segments and different parts of segment links on a triangle. Let's begin by first going over the definition of a median. Now, a median is any line segment that joins a vertex. That, again, let's go over that definition. That's going to be any of these corners. Again, the vertex are the corners of the triangle. And it connects, or it joins that vertex to the midpoint of the opposite side. So we have, again, like you see right here, corner A, the vertex A, and we connect it to the opposite side here, but to the middle, find where the middle is on this opposite side there. This segment here is referred to as the median of the triangle. Now, since the triangle has three vertices, if I connect those three vertices to the opposite side, as you see right here in this triangle, you'll notice that the vertices actually intersect, the segments intersect at a common point. This point here, which I'll highlight in red, is called the centroid of the triangle. And what the centroid does, it cuts the medians into two parts. You'll notice that there's a point from the centroids to the vertex, and then there's a point from the centroids to the middle point on the opposite side, to the midpoint on this segment there. Now, the relationship between those things is the following. If we look at this triangle right here, this point P is the centroid of the triangle. Notice how these 3 points are in the middle, because again indicated by these markers, these respective markers. The distance from A to D is the same distance as D to B, so D is in the middle. So D is a midpoint. And the same thing about E. Notice that E is in the middle because the distance from B to E and E to C are equal, again, as indicated by those markers there. So DE is also a midpoint, and the same thing is going to be true about F. F is also going to be a midpoint. So D, E, and F are all midpoints. Now, the interesting part about that, the interesting part about having this point here, this centroid here, is that these medians are cut into two sections, and the distance from the centroid, from the centroid to the midpoint, to this midpoint, to the respective midpoints, is that those distances right here are equal to 1/3 the distance of the actual median. So, in other words, what I'm saying is this, that the distance from P to E is equal to 1/3 the distance from point A to point E, which again is the link, which is the median. So from the centroid to the middle point is equal to 1/3 whatever the distance from here to this endpoint are going to equal to. So for example, if the point A to E, which again is this segment right there, okay, the median, if the length of this median is equal to 24 units, then the distance from point P to point E, which is the shorter end of this median, is going to be 1/3 that distance. So if I divide 24 by 3, if 24 divided by 3, which is equal to 8, then the distance is going to be 8 units long. And since this entire distance has to be 24, I can figure out the distance from point A to point P by then just doing a little subtraction. The distance from point A to point P, again, since the entire thing has to be 24, from the segment addition postulate, then if I just subtract those two values, 24 minus 18, that's equal to 16, is equal to 16 units. That's equal to 16 units. So look at that. Now, sorry for the long pause. So this is going to be true with every single median. So let's look at this median, the distance from P to F. B to F. So let's say the distance from B to F is a different value. It's not going to be as long as this one. Let's say it's a little bit shorter. Let's say it's 21 units. So that red line is equal to 21 units. Then the distance from the centroid, from the centroid point P to F, the middle point again, which is a shorter end of this median of this red line, that's going to equal to 1/3 of 21 of that length right there. So from P to F will equal to 1/3 that. Well, 21 divided by 3 is equal to 7. So that's going to be 7 units. 7 units long. And because again, this entire red line has to be 21 units long, if I do 21, I subtract again this 7, 21 minus 7, that's equal to 14. This distance would have to be 14. So the distance from point B to point F is going to be 14 units long. And look at this. It just seemed like a coincidence the first time, but the 8 and 16, 8 is half of this distance. So 8 times 2 is equal to 16, which is the same thing that happened here. 7 times 2 is equal to 14. And I didn't get that by multiplying. I got 14 again by subtracting 21 minus 7. Because again, this entire distance has to be 21. So I know that this distance again, because again, that's what the relationship is from the centroid to the median, it is 1/3. So 21 divided by 3 gives me 7. And 21 minus 7 is 14. Because again, remember, this entire line has to be 21. 7 plus 14 is equal to 21. But I also noticed that 7 times 2 is equal to 14. Just like 8 times 2 is equal to 16. Which again is going to be true. And first, not just a coincidence, this is true every single time. That the distance from the centroid to the vertex is going to equal to twice the distance from the centroid again to that middle point, to that midpoint on the opposite side. So in this case, that would be point E. So knowing what the distance of the median is, we can identify then the distance from the centroid to the middle point, and then use that to figure out the distance from the centroid to the vertex by simply multiplying that number by 2. So let's look at an example with some actual numbers here, all right? Now remember that since P is the centroid, then these points here are midpoints. M, N, and O are midpoints. They have to be in the middle because again, the centroid is the intersection of the medians. So this line is a median, this line is a median, and this line right here is a median. So that means that these 3 points have to be in the middle. M, N, and O have to be in the middle. And that's going to be important again in this example because the distance from J to K is 22. So this entire green line right here, that's equal to 22 units. And since M is in the middle, 22 divided by 2 is equal to 11. So that means that the distance from J to M and M to K have to be the same. So they both equal to 11. And the distance from K to N is equal to 13. And again, since N is in the middle, that would mean that the distance from N to L is also going to be 13. And finally, we're told that OL is 18. And again, since O is in the middle, that means that O to J is also going to be 18. And with that information there, we can now again find the segments that we're interested with. So the distance from point K to M, that right there is 11. NL is 13. KL, which is this entire distance right there, that'll be 13 plus 13, which is 26. JO is 18. And JL, J to L would be 18 plus 18, which is 36. So let's look at a second example. So on the second example again, we have that G is the centroid, so our centroid. So that means again that these segments, are medians. So B, D, and F are all in the middle. Let's begin with the fact that A to G is equal to 8. So here on this median here, the longer end of the median is equal to 8, which means that the shorter end of the median would be half of that number. So that's going to be 4. Now, the second piece of information we're given is that the distance from G to F is equal to 7. Therefore, that would then imply that the longer, again, which is part of this median here, all right? And since this is the shorter end of the median, because we're going from the centroid to the middle point, so that's the shorter end of the median, the longer end of the median would be twice that distance. So that's going to be 14. And finally, we're told that the distance from B to G, that distance right here, which again is the shorter end of this median, is equal to 5 units. So the longer end of that median would be 10. So with that information, again, let's fill in the blanks now. GD is equal to 4. G to D, that's 4. A to D, which again would be the entire median, will add 8 and 4. So the answer is 12. G to C is 14. G to E is equal to 10. And B to E, which again is the entire length of this median, will add up 5 and 10. So that's 15. Let's move on to our third example. On our third example, again, we have that V is the centroid. And we're starting off with that the distance of RS is 21. So this entire line, median, this entire segment here has a length of 21 units. Well, since that entire segment has a length of 21 units, then that would mean that the short end of that median, which is from the centroid to this middle point right there, is going to be 1/3 of 21. So if I get 21 and I divide it by 3, I get 7. So this has to be 7, which means that the longer end is going to be twice as big. So that's going to be 14. Now the second piece of information we're given is that the distance from V to U is 8. So the longer end of that median would be 16. And we're also then told that PT is 21. So that's this median from point P to the opposite side. Again, T is in the middle. So that distance right there is 15. So if that distance right there is 15, then that would mean that from the centroids to the middle point, the shorter end of that median would be 1/3 of that distance. So if I divide 15 by 3, I get 5. And that's how long that segment here is going to be. That segment there is 15, which means that the longer part of that median from the centroid to the vertex is going to be 10. So we can then again fill in the blanks. So SV, that's equal to 7. That's from the centroid to the midpoint to 7. V to R, that's equal to 14. Q to V, that's equal to 16. And Q to U, which again is the length of this red median, is going to add 16 and 8. So 24. P to V, that's equal to 10. And V to T is equal to 5. And there you go. And try to do this one by yourself. So on this example, now that you've unpaused it, let's check your answer. So G is in the centroid, all right? So G is our centroid. And we're first given the fact that, again, G is our centroid right there. And we're first given the fact that AC is equal to 64. So A to C, this entire segment there is 64. Well, again, since G is a centroid, we know that F is in the middle because this is a median. So point F has to be in the center, which means then that the distance from A to F and F to C, these two have to be equal. So 64 divided into 2 equal parts is 32. Oh, I missed the fact that BF is 72. So the distance from point B to point F, which is this median here, is 72 units long. Well, then that would mean that the distance from the centroid to the midpoint is going to be 1/3 of 72. So if I get 72 and I divide it by 3, that's equal to 24. And if that's 24, then the longer end of the median is going to be twice as big, which is going to be 48. And the last piece of information we're given is that the distance from point G to E is 27, which is the short end of this median. So the short end of the median is 27. That means that the longer end of the median would be twice as long. So that's going to equal to 54. So we're using that information. We can now find out that the distance from A to F, again, is 32. F to C is also going to be 32. B to G is 48. F to G, or G to F, is 24. A to G is equal to 54. And A to E, which is the length of this green median here, is going to add 54 and 27. So that's a total of 81. Let's see, let's try a second one again by yourself. So try this one by yourself. All right, now that you've unpaused the video, let's see if you got these correct. So if T is the centroid, again, Notice again that these three have to be in the middle, because again T is our centroid. And the first information that we're given, we're going to start off is that Tn is 16. So that's this distance right there. That's equal to 16. Well, that's the longer end of this median, again, that I'm going to highlight in yellow, of this median here. So if that's the longer end of that median, then it means that the shorter end of the median will be half of that distance. So that's going to equal to 8. The second piece of information we're given is that MQ is 23. So from point M to point Q, that's 23. Well, Q again is in the middle. So Q to P will also be 23. And the last piece of information we're told is that PR is 18. So that's this median. The distance of this median here is equal to 18. So that would imply then that the distance from R to the centroid, which is the shorter end of our median, would be a third of that. So dividing that 18 by 3, which is equal to 6, will give us the length of that segment there. And well, if that's 6, then that means that the longer end is 12. So therefore, QT is equal to 8. QN would be adding 8 and 16. So that's equal to 24. Q to P is 23. M to P, which this entire distance is right there, that would add those up. So that's going to be 46. R to T is equal to 6, and T to P would be 12. And then that finally brings us to our last example. So again, pause the video, fill out this information, and then we come back and check on it. So now that you've finished this, let's check if you got this correct. So we'll start with the first thing that we're told again. Well, first we're told that H is the centroid. So obviously these 3 points are in the middle. We'll start with the fact that the distance from D to F is 50. So that means that this segment here is cut into 2 equal pieces to the left and to the right of E. So that means that this segment from D to F was 25 and E to F is 25. Now, the second piece of information we're given is that CF is 42. Well, the distance from C to F, again, which is this median there, when divided by 3, will tell me the distance from the centroid to the shorter end of that median. Well, 42 divided by 3, that's equal to 14. And if the shorter end of that median is 14, then that means that the longer end of the median, which is from the centroid to the vertex, is going to be twice as big. So that section would be 28. And then finally, we have that BH is 22, which is the longer end of this median. And I know it's the longer, not just because I'm just looking at it, it's because from the vertex to the centroid, the vertex to the centroid is always going to be the longer end of the medians. So again, this is longer than this point, then that's a segment. In this segment here, the distance from D to H is longer, and on the red median, again, this end is going to be longer. So like I was saying, since this is the longer end of this median, and that's 22, then the shorter end would have to be half of that. So this would be 11. Bringing the length of this green line to 33. So H to E is 11. E to F is 25. H to F is 28. D to E is 25. C to H is 14. And the distance from point B all the way to point E, again, adds 11 and 22 together to give me a total of 33. So those are the links of each of respective segment. Now this concludes this video on the centroids and the medians. And again, thank you again for watching. I hope this was very helpful and again easy to follow. If you haven't subscribed to my channel, I ask again that you do so, and you click on the notifications button to get updates of when I add new videos. But again, thank you for watching, and I hope you have a great day.